Today I'm here in the lab and we are going to determine the empirical formula of a hydrate. Hydrates are actually really common. You've probably used them in the past and you didn't even know it. For example, I have some copper sulfate here, and then the container just says copper sulfate. But it's actually a hydrated version of copper sulfate in that it's got these water molecules loosely embedded within the crystal structure. So we kind of know the general formula for this hydrate. It's going to be copper sulfate, CuSO4 dot waters. But we want to figure out how many water molecules are surrounding each unit of copper sulfate. So to do that, we will measure some of this copper sulfate, about 1.5 grams. I'm going to run 2 trials. I'll see if I can do one trial really good, and then I'm going to try to do the other trial kind of bad. So let's go to the balance. Okay, so as I walk you down the line, here's my electronic balance. We're going to use these porcelain dishes. They're called evaporating dishes. And that's exactly what we're going to do, evaporate the hydrate. Now, one thing that I will want to record is the mass of the empty dish. So I'm going to record this number. The mass of the empty dish is 52.39 grams. Empty evaporating dish, 52.39 grams. Okay, then you kind of remember, let's see if you can see this a little bit better. You can kind of see it, that there's a button called 0. So I can zero this out, and then I can just add in approximately 1.5 grams. That doesn't have to be perfect. I just have to know the exact amount that I'm using. I might get rid of some of that. It's a big chunk in there. I'd rather not have a big chunk. But I can live with this. 1.69. Good enough. It's totally fine. 1.69 is my first. 1.69 grams. And then just for kicks, I'm going to zero this. Put on a second dish. And I might just record the mass. I'm kind of curious. We'll run 2 trials, but I'm going to try to make one trial better than the other. So we'll try to sprinkle in approximately 1.5 grams. That's a little bit like 2.5. But I'm going to go with it. This is going to be my bad one. Although, can you kind of see that what this looks like? It's a really pretty blue crystal. That's the hydrated version of the copper sulfate. Okay, so now to the ring stands. So I've got 2 ring stands set up, and underneath is a Bunsen burner. So here's the first one that'll go up on top. There we go. And the second one is also going on top of another ring stand. Okay, so now all we're going to do is try to gently heat. So this one, that's going to be like my better trial. I've got pretty far from the Bunsen burner flame, and we'll adjust it so that the flames aren't totally scorching this thing. But my other one I've got set a little bit lower. So I'm going to try to heat this one a little bit stronger. All right, so let's turn on the burners and see what happens. Gas, flame, gas, flame. All right, this one I'm going to turn down just a little bit, just so that we gently heat. Okay, so we're heating, we've got flame, and then let's see what's happening. Now this one I'm heating a little bit stronger, and it might be hard to see because the porcelain dish is white, but the outside of the crystal will also start to turn white. Dial in on that one a little bit. Like the edges will start turning white. When you start heating, you want to make sure that you have kind of an even layer on the bottom so that all of the crystal heats evenly. If I had a big chunk well, then it might be that the outside parts are heating, but the inside chunk takes a little bit longer. I want to try to make sure that all the particles are about the same size. Here's my top one. This one you can kind of tell. Do you see how the outside edges are starting to turn white? We're just evaporating the water from the hydrate. The anhydrous salt, copper sulfate, is a white solid. Sometimes you can even kind of see it like snap, crackle, pop a little bit. Like you can kind of see it almost like boiling, like the water is evaporating. Ooh, that one's heating nicely. And then here's my second trial. Oh yeah, there's quite a bit of white in that one now. Just the inside is still a little blue. So let them heat for a bit. Fire! There we go. This one's getting close. I want to heat until it's a uniform color. So it's helpful to kind of know what color you're looking for. In this case, the anhydrous form of copper sulfate is white. So I'm going to heat it till they're all uniformly white. Here's the top one. There's just a little bit of blue in the middle. And here too is where you want to make sure that it was a nice even layer so that it heats evenly. This one's getting close. Nice. Now if I overheat the hydrate, which is what I'm going to kind of try to do with this one. So right now this one looks pretty good. It's all white. I probably should stop, but I'm not going to. I'm going to let this one go a little bit longer and see if we can overheat this one a little bit. If I overheat the hydrate, the edges will start turning brown. And instead of just copper sulfate, I'm going to start driving off the oxygen from the sulfate group. And then we could end up with like copper sulfide. And that I don't want. Can you kind of see some of the edges are starting to turn brown a little bit? There it is. I really should stop heating it. But this one I'm okay if it turns kind of bad. Let's see how the top one's looking. Now that's better. That's pretty good. There's just a tiny bit of blue in the middle. So maybe we'll let that one go for just like another 30 seconds or so. And then we're going to take them off the heat and eventually we'll remass. So the change in mass really should just be the water that I evaporated. Another problem with overheating, like in the second one that's starting to turn a little brown, if I overheat the hydrate, sometimes it kind of pops out of the dish and it seems as though you lost all of this water, but really it wasn't all water that we lost. We lost some of the salt. If it like snap, crackle, pops and jumps out of the dish, that I'm not looking for. There, so that one's getting nice and toasty on the edges. But then my good one, that looks pretty nice. Nice and white. This one, maybe a little bit brown. So that one I probably should have stopped a bit ago. But I want to at least kind of show you some of the common errors. We could overheat a hydrate and start to change the composition of the salt. If we overheat the hydrate, it could kind of pop out of the dish. I don't want that. I want to just heat it until it's a nice uniform color, which it is. All right, so we can turn the gas off. Turn the gas off. And then we'll use our trusty hot hands because it's hot. So we're going to take this off the ring stand, and then we're just going to let it sit on the table for, maybe 30 seconds or so. There it is. We're just going to let it cool before we put it on the electronic balance. You never want to put something that's scorching hot right on the pan of the electronic balance. Now, the other one, I'm not so worried about. That was my bad trial. But now we'll go back, turn on the balance, and we'll see what we got here. Okay, so the difference in mass should be any water that we've removed. Let's see how we did. All right, so it's going on the balance again. There it is. There's the balance. Okay, so now I'm at about 53.40 grams. When you make a measurement on the electronic balance, you do not need to estimate. It's just 53.40. I'm going 40. I'm going to write that down. I'm going with it. 53 point, went back to 1. 0. I'm saying 0. 53 point, I know it's on 1, but I'm going to say, fine, 41 grams. Oh, now it's back to 0. Of course it is. Okay, well, I already wrote it down. 53.41 I'm going to write. Now, we do want to measure the mass somewhat soon after heating. There is water vapor in the air, and so if I were to come back, I don't know, like 20 minutes later, well, now we might have a problem in that the hydrate could start to absorb moisture from the air. It essentially rehydrates itself. So while you don't want to mass it immediately after coming off of the flame, we don't want to wait forever and take the chance that it starts to reabsorb moisture from the air. Okay, so at this point then, I'm going to record any changes observed as the hydrate heated. So hopefully we just saw the nice color change. It turned from a light blue to white. It's pretty uniform in color. And I did not see any solid like flying out of the evaporating dish, which sometimes happens. But we're trying to heat this one pretty gently. Awesome. Okay, so really that's all the data we need to record. But I want to show you one other thing that's kind of interesting about a hydrate. So right now we have the anhydrous salt. So we've got the copper sulfate without water. Well, eventually we got to clean this out, right? And eventually when I clean it out, I'm going to add water. And so watch what happens. Let's see if I can get this a little closer. There she is. Okay, if I start adding water back to it, so here's just water. Now it's obviously hot, but look at that. It goes back to the exact same blue. It just rehydrates itself. So now I'm back to the original color and eventually the original hydrate. How cool is that? All right, so we've got the data, we've got some observations, and now all we got to do is some calculations.